right now. So it's kind of, she thought it'd be great for me to give this talk. And so here we go, we're back. I'm sharing my screen. Hopefully that'll work. So here I'm trying to find a shortcut for image prep. And so I've got this full-size image. I want to crop it. And so I'm using Cloudinary. And what you do with Cloudinary is you upload the full-size image. And then it gives you a URL. And then I added these terms in the middle of the URL. It's saying crop it in the center to 1,000 high by 1,000 wide. Then you see a couple more parameters, which disappeared. All right, let's go. There it is. All right. Q auto is lowering the quality to the optimal, it's lowering the quality of the image, but to where the human eye can't tell the difference. It's getting an automatic format, so it may be serving WebP to Chrome, and I get a 120K image. And this is great, because now I can automate a center crop of all of my images, which is really, really great until I get an image like this, and I center crop it, and it's not exactly what we're looking for. But what's really kind of cool is built in, they've got some enhanced intelligence into their images. I could do a manual crop. That's not really automated. But they have a thing called gravity of the image. Gravity Auto finds the thing that's probably the most important in the image. So it's got some AI behind it trying to figure out where things are. And then I crop it to around the thing that's of the highest gravity to 1,000 by 1,000, and it actually gets what we want, right? It's finding the image, it's finding my face and centering it. It's sort of off-center, but you get the Swiss flag and the Alp, and so that's kind of cool too. And this is done in a lot of different websites. So actually, as part of my traveling, when was this? This was in May. I was in Poland, and my son is a World War II, really interested in World War II. And this is Hitler's bunker, where he spent most of World War II. And it's literally a one-story building with 15 meters of concrete put on top of it because he was really worried that he'd get bombed, rightly so. I posted this as a tweet, and Twitter finds the thing that's most interesting in the tweet, and it looks like this, right? So they found the door and centered the image around the door of Hitler's bunker. Twitter uses Cloudinary? No, they don't, but they have a similar AI that's finding the things of interest in the tweets. A friend of mine went to the Taj Mahal, and actually what was interesting is the AI centered on the people at the bottom, not on the seventh wonder of the world at the top of the image. Because in the most part, it's not the buildings that people are interested in, it's the people. So like these things work, but they also don't work. But in this case, you know, it sort of found something of interest, because if it had centered on like the moss growing on the concrete, people would be like, what the heck is this a picture of? It doesn't even make any sense. It's really neat. As the Germans were leaving, they blew it all up, and there's trees growing out of all these concrete bunkers. It's really kind of fascinating. Anyway.
You should have an AI where basically you would find the thing that you're missing in the caption.
So we're going to talk a little bit. I'm going to try to get to that a little bit. So that's really neat. Like, so there's tools that will just sort of like decide it for you. These are the most important objects in your image. But it'd be cooler if you could actually decide what you want to look at. And so this is the image AI library. It's based on TensorFlow. You need an image model library. If you just look up image AI, there's a lot of Medium posts. They walk you through this. And so they give you a library, and I set up an image. This is Berwick upon Tweed in England. And I ran it through this thing saying, find everything of interest in this image. And it did. You see all the boxes appear, right? It found the bus. It found cars. It found people, right? So it's finding these things because the library is trained to look for people, to look for cars, to look for buses. If you look really carefully, it found the clock, right? I think that's when I was looking, this is the other results you get, and I was like, clock? Where the hell is there a clock in this image? And I went back and I'm like, oh, there's actually a clock, and the AI found it that I hadn't actually seen. And in this case, it gives you a box with, X, Y of the upper left corner and the bottom right of where these things are that it's identified. And it gives you, with like an extreme accuracy, that's probably way too many sig figs, how certain they are that something's there. So they're really sure about this car, not really so sure about that car. And if you actually look, it's the bollard. Like, it thinks that that's a car. It screwed up that one, and it screwed up like that sign it thinks is a car. But the other cars, it did a pretty good job. Like, that's actually really interesting. So if you wanted to center this image and crop it around a bus, you could find the bus and make a 1,000 by 1,000 image centered around that bus. It'd be pretty easy to do. So because you have this library that's been trained to identify cars and buses and clocks and people, it doesn't get all the people, right? Yeah, it missed some of the people. It missed a bunch of the cars. Right? I mean, so it's not getting everything, but it's
an algorithm decision. Too far away, too small.
And it might not be able to discern that this shape of a person is kind of hidden by like the wall, and these people are so close together, it looks like a two-headed person. Right, so it's not perfect, but this object detection can be used for cropping, like I sort of did with my picture. You can use it for blurring objects. Like if you go to Google Maps and you do, like, it blurs out all the license plates. So it identifies the license plates and blurs those out. You can also remove objects. And so this is in Munich, in the center square, and they have enough pictures that they can recreate the cobblestones, except for where the guy's boots were. I assume it's a guy. I'm going to say it's a guy. So like I have a short link right there if you're interested to see this, because it's actually kind of funny that, you can walk around this square in the middle of Munich and there's just this pair of disembodied boots in the middle of the screen. But it's able to remove all the rest of it because it had enough other images that it can recreate everything around it. You can also do stuff like create alt text. So in this case, this is a picture of me and a couple of llamas. And it would say, alt, a person and two dogs. And of course, the problem here is that this library was not trained to identify llamas, which is sad. It's really, really sure that these are dogs. Like 88 and 96% sure that they're dogs. They're not dogs, they're llamas. But there's a website called llama.vision that has a library that's trained for llamas and alpacas. And when I go to that webpage on my phone and I point it at this slide, it identifies the llamas on my slide. So it all depends on the library. And this sort of goes back to like sort of the ethics of machine learning, right? If you don't have a well-trained model, you're not going to get really great results out the other side.
There's an example of not recognizing a black person.
Well, black, yes, there's stuff like that. The other one that happened to Amazon is because they weren't really great at bringing in female candidates. They were using the logic of who they rejected in the machine learning tool, and the machine learning tool was actually rejecting everyone who graduated from an all-female university because the data that they fed in was causing all of the women to be rejected, and so the machine learning algorithm continued rejecting them. Right? So there's a lot of ethics and things you have to be very careful about when you're doing this. I'm looking for llamas, right? I'm going to keep this really, really low key, and I'm trying not to get into that. Like, my library didn't find a llama, and so like, I'm not saying that library is against llamas. It just wasn't trained.
So does it identify dogs as llamas?
No, well, so you can have false positives, and we'll talk about that. But no, I don't think the library I was using doesn't even know what a llama is. So it's like kind of talking to a 3-year-old who doesn't know what a llama is, and they're like, doggy, right? That's what the library is doing. Whereas this one over here is a little bit older, and it's like, I know what a llama is. That's a llama. But it's a really dumb algorithm because that one might only know about llamas, alpacas, and camels.
Yeah, that was my question.
Right. If it's only trained, it only knows what it's trained to know. And so if you don't train it to understand something, it won't work. So I thought, I'm going to train a model. And I had just gone in a ropes course, and I like put my finger in the screen. I'm like, I'm going to train a model to identify fingers in the screen. I mean, it's kind of dumb, but it's kind of fun too. So I walked around and took pictures of my dog with the finger in front of the screen. And then I used Google's, they've got an object identification library where you upload a bunch of these images and you say, here's where the finger is. And so you're training the model. You're saying, hey, here's an image. There's a finger in it, and it's right here. It's inside this box. And then I found this image on the internet, and I said, hey, look, that's where the finger is. And again, and again, and again. I found some online. I took some myself, right? And so I put like 30 or 40 of these up into the tool, and I trained the model saying, these are images. That's where the finger is. See what you can do. And what this is saying is the precision is 83%, which means that how often is correct. So 1 out of 6 is a false positive. So it sees a finger, but it's not right. How often it misses. So it misses 1/6 of the time. Again, like I did this with 43 images, right? The more images you do, the better you train it, the better it's going to work. So this model is up on Google. I can deploy it. I can write a Python script and say, hey, here's an image. Tell me if you find a finger. And so I sent this image up, and it said, I said, get the prediction. Here's the URL. Tell me what you find. And it comes back. I found it. It's inside this box, and we're 98.9% sure that it's a finger. And so I drew the box where it says it is, and lo and behold, yes, indeed, it discovered a finger. And so now, because it's identified that finger, I can start optimizing the image. So in this case, I just wrote some code in Python. I said, hey, if it's longer this way, crop it vertically. And if it's this way, just crop off the top or the bottom, wherever it is. And so I get an image that looks like that. And it fixes the problem, right? It just cuts off half the bit of the image that has the finger on it. So like, just going back really quickly, like this image would be kind of useless because you get half of the one woman's face and then the other woman, like you've lost most of the image. But, you've gotten rid of that problem. I thought we could maybe be a little cooler. There's some cool stuff called in-painting. And what in-painting does is it tries to fill in that space with the colors of what's around it. And there's some really neat demos of people doing this where they've like trained a library and they can move their smartphone around and it like, there's some really neat stuff going on. But I said, this is the area I want you to in-paint it. And so, a little bit of Python here saying run this in-painting. It's part of OpenCV2. And this is the streaky one. And so what it does is it takes the colors at the edge of the box and just smears it across. You can kind of tell that there was something going on there, right? That's not really all that great.
And yet it, on the side, from the bottom, so that we're diagonal.
It's going up, and then it just kind of meets in the middle, right? That's just the way the algorithm. And then there's 2 algorithms in OpenCV. Then there's the blurry one, and the blurry one's a little bit better, but it's still like it's not quite there. It works really, really well if it's like a blue sky. Like on that blue sky, it worked really, really well. Like it got rid of that, and you might even not even notice. Like there's a little bit of color weirdness going on, but it doesn't work very well at the bottom, right? Because it's working on a rectangle. Like if I could do an ellipse and just find the circle where the finger is, it'd be great. But because my rectangle hit this, it's smearing the buildings up and across. And so that just kind of looks like crap. And obviously you wouldn't do that.
It'd be interesting to maybe take it and replace it with like a piece of like wood grain or something like that, or like a frame.
Yeah. I mean, I think the trick would be if you did a frame, you'd still be cutting off like half of the building right there. So I tried to trick it by removing the outlier colors in the border. So if I can get rid of the outlier colors where the building is and then make it blue, then it will smear a lot nicer. To trick it, I turned it to grayscale because then I only have 256 colors. I did some k-means to find the colors that were there. This is the code. It will be up on GitHub soon, but I need to clean it up a little bit yet. And it finds the 10 most common grays, and it tells me where they are and how frequent they appear. So I loop through all the colors. I ignore the white center of the box because I'm making a box here, right? And the center is white. That's the most common color in the box. And then if it's an outlier, I mask it with the most common color in the thing. And it ends up looking like this, right? So you can see I got rid of a lot of the black that was up there and a lot that was down here. It's still not perfect. I'm still working to perfect this algorithm. But when I in-paint this, it actually looks a lot better because I've sort of cheated. It's better. It's not perfect, but it's better. We're getting there to where it sort of looks like the sky. Now, granted, it sort of looks like the building is going away, right? But, you know, I'm playing with this. I'm trying to learn how to do it. So this is just sort of learning what's going on. But it's definitely an improvement from that. So, you know, we're playing with this. I'm trying to learn how to do this. But as I was doing this, I started talking to a guy who works for a sunglasses company. And so on their website, they have hundreds of images that look like this. And they want to do what's the biggest thing when you try on sunglasses? You want to see if they look good on your face. They want to do something that will put it on your face, right? But the problem is all the images have this lens thing right there, and that would look really weird if you put that on your face. So like you could hire a summer intern and say, here's Photoshop and like start cropping, right? That would be the old-fashioned way to do it. But I'm going to do this, and we're going to use the tools that we just talked about to remove the arms from the sunglasses so that it looks like that. All right. So the first thing we want to do is remove the background, right? Because obviously this white kind of blocks out someone's face. There are a lot of tools that will do that. There's a remove background web page that you upload a photo and it'll remove the background and give you the new image. It does it automatically. Again, Cloudinary will do this. As you upload it, you say just remove the background and it'll do it. It'll give you the image and it looks like that. That's still not great, right? Because I still have the arms in place. The next thing I did is in Cloudinary, you can do fun stuff in the URL. So I'm making it transparent with only 70% opaqueness. And so that means my eyes peek through that image that I'm placing over my face. But we still have those arms. So we're going to go back and we're going to train a model, right? And so I took like 50 images of sunglasses and I trained it for the temple, for the arm, and for the tip. And you might be like, well, why the heck do you did so many? You could have just drawn a box around one of those. Well, remember how like if the box was too big and it hit the building, it was smearing in. A lot of sunglasses, if I drew one box, I'd be hitting this and it would smear in the black. And we don't want that. So if I can draw it with the temple, the arm, and the tip, I found that I wasn't ever hitting the frame when I was removing it with in-painting. So I trained the model. So I took like 40 images of sunglasses. And with this Google tool, you can tell it the XY coordinates if you know where everything is. Or it has a UI on the web where you just click and drag, and then you assign it temple. And then you click and drag and assign it arm. And then you click and drag.
What tool is this? Sorry.
It's Google. It's the Google Object Identification machine learning tool. And you just, it's got a user interface on the web where you can click and drag all the boxes. Then there's some funny stuff where you have to upload the coordinates, but it requires a CSV file, so you end up with just like 11 commas that are blank, and then you draw the boxes, and it fills it in for you. But they walk you through it. There's a tutorial that walks you through all of this, so it's actually pretty easy to do and straightforward to follow along. So I've got a pair of sunglasses. It finds the temple, the arm, and the tip. If you find an odd number, it fails, right? If you find an odd number, like here, the Ray-Ban was causing the problem here. It can't find that one in the corner. But it finds them. I can in-paint it, and they're gone, right? So now I can take all of this together. I take a picture of me, and I can use the Gravity Auto to center on me, right? And then I can take an image of sunglasses that I've removed the lenses on. I can make it transparent, and then I can apply that onto my face. And so obviously those are really horrible sunglasses for me, but it worked. And so what I did here is when I uploaded these sunglasses, I gave them a label. So I take the image, I send it off to Google. Google tells me where everything is. I remove it with Python. I upload it to Cloudflare with a label, and then I can place it over the face. And then the full URL, it gets really complicated, but I'm cropping my image around my face, and then I'm taking the labeled image, making it transparent, and putting it over my eyes. There's an API that'll put it over your eyes, and then apply it, and it works. And so we can actually do this live because I've got my thing running. And so, where's the? All right. So this is the web page for a sunglasses website. And if you just change this number here, you get a different pair of sunglasses. Right? So I can take these sunglasses, and here's my Python script. And so the Python script says, run glasses pi. This first is the picture of Doug, and then the second one is the picture of the sunglasses. So now it's going to grab the picture of the sunglasses, send it up to Google, identify where it is, the arms are, remove them, and then apply them to my face. And it takes a second to do that, but there's the image to the URL. You can see that it found 6 objects, which is important. If it finds an odd number, it looks weird. But I've got the URL, so I can pop that into Chrome.
You could have the Python script just open it directly.
I could. Right, this is just proof of concept that it works. And you can see here that it actually had a little problem. It actually removed more of the lenses. And I think the reason for that is, if you actually look this right here, it thought that was part of the transparency when I made it transparent. So, like, it works for most sunglasses, but it doesn't work for all. So let's try 7, 7. There's a different pair of sunglasses. We'll go for it. If you don't know that, if you hit Control W, it removes the last parameter in the command line. It's super cool. So I'll just show you, like, once it's done. So you don't have to hit delete for that whole URL. You just hit Control W and it removes all of it. Like, whoa! Without, my mind was blown when I learned that one. And it sort of works. So now you've got this API that this sunglasses company can put on their website, try it on my face. You upload a photo, and bam, it all works. You could imagine that they would already have all of the sunglasses made transparent. And I mean, I'm doing all the work all at once. They could make them all transparent all in one swoop, and it would all work. So I think that's really cool because I was able to take all the sort of stuff that I was studying in AI and make it all work.
Another potential thing is you could potentially find the circle in the sunglasses.
Yes. Except for sunglasses, they're not all circular. Like, they've got weird ellipse shapes, and some of them aren't even ellipse shaped. And then you start thinking about like cycling sunglasses, which aren't even round. Right? So there's always, you're right, but there's always going to be an outlier where it's going to be weird. All right, but it works. And so we can use image processing with AI and machine learning to crop, blur, remove objects. We can do the alt text. And I think it's kind of fun. So thanks for listening. This is a fun tool for me to learn about machine learning. Thank you. And you've asked a lot of questions, but I'd be happy to take more questions if you have any right now.
So when do you think it'll be up?
I'm cleaning out a garage all this week, so probably like the next week in July, I'll have some time to do it.
You could combine it with your other projects. Like, what if you gave like the Mona Lisa sunglasses?
So have you seen some of the stuff they're doing with machine learning in the Mona Lisa? It's freaking terrifying. Yeah, here it is. The Mona Lisa brought to life. So they took one photo. They took the Mona Lisa. Oh, good God. I don't want all that crap.
Represent a system that can learn realistic talking head models. Notably, learning of a new head model requires just a handful of images. In this example, the model was learned from 8 frames.
Let's skip ahead to the Mona.
Networks are trained
Ah, the hell with this. I want the one with the Mona Lisa.
The embedded network is frames concatenated with the
Oh, did I?
into vectors
Let's just try again.
containing pose-independent information.
Here. Good God. Hit this one? That's a video. Okay, Mona Lisa brought to life. We'll just find a... It may be on that video, but it was long. I'm impatient. Here, the Telegraph has it, right? So they took the picture of the Mona Lisa and they had an actor in the background. Oh, yeah, beach vacation.
They search millions of homes to find your perfect beach.
Yeah, all right. So, like, they took the Mona Lisa and, like, that one image, and then the actor, they could make the Mona Lisa look like it's talking and having a conversation. It's kind of neat, but it's also kind of terrifying because all of a sudden now any video on the internet, you have to be like, huh, did they really say that? Right. Right. I mean, that's deep fakes right there, right? If you could do it with the Mona Lisa, you could do it with a picture of Barack Obama, with Donald Trump, with Hillary Clinton, with Boris Johnson. Name your politician, you can create a fake, right? It really, I mean, I think it's kind of neat, but it's also a little bit terrifying. But I mean, this is sort of where this sort of thing is going, which is also kind of interesting. It's a lot tamer than like having like a politician's, like fake lip reading with different words, right? Yeah, I mean, yeah. Again, like you can use machine learning and you can do all this stuff. You can do a lot of really cool stuff with it, but you can also go to the dark side, I guess. Yeah, for movie. Yeah, I mean, I guess this could keep Stan Lee and all of the Marvel movies going on forever now, right? Because you've got enough footage to Stan. Yeah, you get the idea. Anyway, I think that's cool stuff. So thanks for listening. And then we've got another speaker here. So in the meantime, eat chicken, everyone.